Okay, we're going to go through stoichiometry, the second chapter. So this deals with limiting reagents and working out theoretical yields. So here we have a reaction between iron and sulfur. We're given 10 grams of iron, 10 grams of sulfur. And after mixing them, to put them in a boiling tube and heat it up to bring about the following reaction. Calculate the maximum amount of iron sulfide that could be formed in this reaction. So when we're dealing with chemical equations, we always work with moles. So we're going to try and convert grams of both substances into moles. So let's do that for iron. First of all, 10 grams, and we have a relative atomic mass of 56, and that'll give us the number of moles of the substance. Okay, we do the same for sulfur. 10 grams over 32. Okay, so you can see that even though we have the same amount of grams, we have different amounts of moles for each substance. Now they do react in a 1:1 ratio, as we can see from the chemical equation. There's an imaginary one there. So which one has less? Do we have less iron or do we have less sulfur? You can look at that by looking at the number of moles. So we have less iron than sulfur here. So what we do is we call iron the limiting reagent, because we only have a small amount of iron and we have loads of sulfur compared to it. We only need a 1:1 ratio. So the iron, we only have 0.179 moles of it. Only 0.179 moles of sulfur will react with that based on the equation, because it's a 1:1 reaction. So it says calculate the maximum amount of iron sulfide that can be formed in this reaction. So when you're looking at that, you always work with the limiting reagent, okay, because that's the amount that's going to react, whereas we're going to have a bit left over with the sulfur, okay? So let's write out the equation. So we have 0.179 moles of iron that will react with 0.179 moles of sulfur. Only, we know we're going to get excess sulfur anyway, so that's just going to be left out, it's not going to react. And it's a 1:1 ratio, there's one here as well. We're going to form 0.179 moles here of the iron sulfide as well. And we're working off the limiting reagent amount. So we have this formula, number of moles equals mass over relative molecular mass. We have 0.179 moles of the iron sulfide. We want to figure out the mass of it, and the relative molecular mass will be 56 plus 32. And we found those on the periodic table. Adding them together and then maneuvering the equation around, we will get 15.75 grams of iron sulfide. And that's the maximum amount of iron sulfide that could possibly be formed from this equation. Okay, let's go on to the next one. We have ethene, and it's made from ethanol. 20 grams of ethanol. A student prepared 8 grams of ethene. Calculate the percentage yield of ethene. So when we're looking at percentage yield, we use this formula. The actual yield over the theoretical yield. Okay, so the theoretical yield is how much we should actually get if the reaction fully reacts, if all the reactants react perfectly with the other reactants or if they decompose perfectly. But that doesn't often happen in the lab. So we might get some fluctuation. We'll probably end up with a lot less, depending on the accuracy of the chemist and the situation environment that this reaction is happening in. So we often end up with less. So let's see if we can work out the percentage yield. And first of all, by working out the theoretical yield, because the actual yield is given to us here. We have 8 grams of ethene was actually produced. That's the actual yield. Okay, so we need to work with the 20 grams of ethanol. So let's write down C2H5. The relative molecular mass of that would be 46. And the relative molecular mass of the ethene is 28, just in case you need it. Now, okay, so we only have one reactant, so we're going to be working off that for the moles. There'll be no limiting reactant here. 20 grams divided by 46 will give me the number of moles of ethanol that I have. Okay, now that I have that, we can see that's a 1-to-1 ratio. They're all ones. So C2H5OH decomposes into C2H4 ethene and water in a 1-to-1 ratio. See all that? They all have ones. So theoretically, if I have 0.435 moles of ethanol, I should get 0.435 moles of ethene, and the exact same with the water. And it's the percentage yield of ethene that we want to work out. So we do that by comparing masses. I have 8 grams as the actual yield. So I'm going to change this number of moles of ethene into mass. Okay, there's 12.18 grams, and that is the theoretical yield. How much we should be getting out of it if it was a perfect world. Now, how much do we actually get out of it? So we have 8 grams, and we just compare that to what we should have gotten. Multiply it by 100 to get a percentage. And we will get 65.68%. So that was our percentage yield. Now you can pause if you want and try this one. It's slightly harder. We do have volume in this one, so we're going to have to convert volume into moles, which is an extra step. But apart from that, it's the same. Okay. So I'm going to quickly just going to write up the equation here so I can write under it. And we've got 11 H2O there at the back. So, okay, so we just show that there's more than enough sodium dichromate to oxidize all of the ethanol. So sodium dichromate, this is a half reaction, so you see the minuses. The full reaction isn't written in. So when you're working out relative molecular mass for it, this is what you're going to have to work with, not this. So be careful there. You always use the full compound molecule to get the mass for it. Okay, so let's see if we can find a starting point here. we have 6.9 grams of ethanol, which is this substance here. And you're given the density of it, so we can convert into mass straight away for that. And we're also given the mass of sodium dichromate. So we can work out the number of moles of the ethanol and the sodium dichromate, the two reactants present, and then hopefully work out the limiting reagent from there. And we can see which one is the limiting reagent, either sodium dichromate or the ethanol. So that's our plan. So let's start off there. And we're going to do this by taking the mass, density, volume formula. So we're looking for mass, so that means density times volume. Density of ethanol is 0.8 and the volume that we have is 6.9. And if you multiply those two together, it gets you the mass, 5.52 grams of ethanol. Convert that into moles then, 5.52, the mass, over the relative molecular mass of ethanol, which is 46. That'll get you 0.12 moles of the ethanol. Okay, so that's that one done. I'm just going to write up ethanol here, so that's all relating to ethanol. Now we're going to look at the sodium dichromate. Okay, so I'm just going to write Na2Cr2O7.2H2O. We're going to deal with that. So we have the mass, and we divide by the relative molecular mass of sodium dichromate, 298, and we will get 0.1 moles of the sodium dichromate. Okay? So we need to figure out which one is the limiting reagent. So they do react in a 3:2 ratio. So 3 moles of ethanol will react with 2 moles of the sodium dichromate. So let's see, if we had 3 moles of, if we have 0.12 moles of the ethanol, which we do, that would relate with 3. So I want to see how much one part would be in a ratio. That would be 0.04. So that would relate to like what one part of the ethanol would be, basically a third of the ethanol that's present. Okay. And then 2 parts will be 0.04 times 2, which is 0.08. So in a 3:2 ratio, the 0.12 would react with 0.08. And this is ethanol, and this is the sodium dichromate. Okay, so that's literally the minimum amount, the perfect amount of sodium dichromate is needed to react with the ethanol. So let's compare that to what we actually have. We have 0.1 moles of sodium dichromate. So we actually have more than enough sodium dichromate to react with the ethanol. And that's all you have to write down. That's seeing that we have 0.1 moles of sodium dichromate present, yet the reaction only requires 0.08 moles. It shows that the sodium dichromate is in excess. Therefore, the ethanol is the limiting reagent. And that's the answer to part 1. Okay, calculate the percentage yield of ethanoic acid. So seeing that we worked out that the ethanol was limiting reagent, we're going to work with that. And it says of ethanoic acids. Let me just write down. We have 3C2H5OH. And that goes to 3. So we have our limiting reagent compared to our product that we want to measure. And it's 3:3, so it's basically a 1-to-1 ratio there. And we have how many moles of ethanol? We had 0.12, which means we're going to have 0.12 moles of the ethanoic acid as well. It's a 1-to-1 ratio. So we can work out, because we have the moles, we can work out the mass that we should theoretically get if that reaction happened perfectly. So if you work out the relative molecular mass of ethanoic acid, you'll get it to be 60. And then if you multiply those together, you're going to get 7.2 grams of ethanoic acid. And that's the theoretical yield. Okay. It did tell you how many grams or how many centimeters cubed of ethanoic acid was actually collected, but it's in volume. So you have to go back to your equation. Density times volume. So our density is 1.05, which we see at the bottom here, times 5.4. And we're going to get 5.67 grams of ethanoic acid. And that's your actual. Okay, so now you just put them on top of each other to compare them. And then multiply it by 100. And you're going to get 78.75% yield. And that's those two done. Okay, so if you want to take a look at this one now, it's our last one. All the things that you've learned so far should be fine with this one. It just looks a tiny bit different. It's not in the kind of essay format, let's say. So you have to use the table. And you're going to have to do it twice for 2 different reactions. So I can give you some time, pause it here. Okay, so we have 2 different reactions. It's important to note. We both have ethanol in both of them, sodium dichromate in both of them, but one produces ethanol, one produces ethanoic acid. So let's just work with the sodium dichromate. We see we've the exact same amount in both reactions. So now you need to do this one time to work out how many moles there are. 8.94 divided by the relative molecular mass, 298. And that will get you 0.03 moles of the sodium dichromate. Okay, and that's in, just going to do a little side note, both reactions. Okay, now let's take a look at the ethanol. We have ethanol in both reactions as well, but we have a different amount. So I need to do that separately. So I'm going to say ethanol first here. Okay, so we have 6.9. And we remember density times volume gives us the mass. So 0.8 times the 6.9. And that will give us 5.52 grams of ethanol. Converted that into moles. You're going to take the mass and divide it by the relative molecular mass, which is 46. And you'll get 0.12 moles of ethanol. And just for clarity, this again is the first reaction. Okay, over here we'll do ethanol second reaction. The exact same thing. So 2.3 times the density, and you'll get 1.84 grams. Take the grams divided by the relative molecular mass, 46, get 0.04 moles. And that is for the second reaction. Okay, so we need to compare the ratios now and figure out which one is the limiting reagent in both of them. So let's go here. This is our limiting reagent section. The very first one, 3C2H5OH, 3 moles of ethanol will react with 1 mole of the sodium dichromate. Okay, so we have 0.03 moles of the sodium dichromate. So the amount that we need of ethanol to react with that would be 3 times it, which is 0.09 moles. Now let's just compare that to what we actually have. We do have 0.03 moles of the sodium dichromate. In the first reaction, how many moles of ethanol do we have? 0.12 moles. So it's clear to see that ethanol is in excess, and therefore the sodium dichromate is the limiting reagent here in this one. Okay, now let's do it for the second one. That's the first reaction. So again, we have 3C2H5OH, and that gives us, reacts with 2 moles of the sodium dichromate. So which one is the limiting reagent here? Okay, again, we have 0.03 moles of the sodium dichromate in both reactions. However, it's 2 this time, so you're going to go 0.03 divided by 2 to get what 1's part would be, multiply it by 3 to get what 3 parts would be. And you'll work that out to be 0.045 moles of ethanol needed for the sodium dichromate. Is there enough sodium dichromate in the second reaction? No, because we only have 0.04 moles. So therefore, in this scenario, the ethanol is the limiting reagent. Okay? So there's your 2 limiting reagents figured out. Okay, so now we can work out how much reactant is actually produced. So I'm going to rub this out. Okay. So in the first reaction, the sodium dichromate was our limiting reagent. So we're going to base all further calculations off the limiting reagent. And that will produce 3 moles of the ethanol. And that's just from the very first equation here. So we see we have sodium dichromate and the 3 moles of ethanol. So it's a 1:3 ratio. We have 0.03 moles of the sodium dichromate, which means we should produce 0.09 moles of the ethanol. In a perfect world, this is the theoretical yield. So moles to mass will be 0.9 multiplied by the relative molecular mass, which is 44 for ethanol. And we'll work that out to be 3.96 grams of ethanol, and that is the theoretical. Compare that to the actual yield, which is given to us. 1.62 divided by 3.696. Multiply that by 100. And we will get 40.91% yield. And that's the very first one there done. Okay, let's wipe this out and do the second one. So the second reaction, we worked out our limiting reagent to actually be the ethanol, because we didn't have enough of it to react with the sodium dichromate. So that's our limiting reagent, and we worked that out to have a certain amount of moles. But before I get to that, I'm just going to write out the equation. And we always base the amount produced based on the limiting reagent. So that's why I'm using ethanol this time instead of the sodium dichromate. Okay, it's a 1-to-1 ratio this time. The amount of ethanol we actually had was 0.04. So that's going to produce 0.04 moles of the ethanoic acid. Okay, do the exact same thing. Work out the relative molecular mass of the ethanoic acid and multiply it by the number of moles. And you'll get 2.4 grams. And that is your theoretical yield. 2.4. And then what we actually got was 1.73 times it by 100. 72.08%. Okay, and that's how you work out the limiting reagent and the theoretical yield from masses, if you're given moles or if you're given volume.